when we started, there was hardly anything in scientific literature in this area, right? We had to do a lot of experimentation and a lot of going down the wrong path, coming back. In that kind of situation, you're less likely to build an MVP because you don't want to jump straight to a solution. And what you're more doing is saying, do I understand this industry well enough to believe that this is such a big problem to solve that it's worth spending multiple years on this topic? And in our case, we were so embedded in the industry that it was pretty clear to say, yes, we understand this well enough to know there is a problem, and the problem is really big and it's worth spending this time on. My name is David Hartmann. I'm the CEO and founder of Helio Additive.
This is Code Story, a podcast bringing you interviews with tech visionaries.
Like 6 months moonlighting.
There's nothing at the back end.
Who share what it takes to change an industry.
I don't exactly know what to do
took
next.
many goes to get right.
Who build the teams that have their back.
The company is its people.
The teams help each other achieve. I was proud of our team.
Keeping scalability top of mind.
All that infrastructure was
Yes, we've been fighting it as we grow.
Total waste of time. The stories you don't read in the headlines.
It's not an easy thing to achieve, mind
Took it
you.
off the shelf and dusted it off and tried it again.
To ride the ups and downs of the startup life.
You need to really
It's
want it.
not just about technology.
All this and more on Code Story. I'm your host, Noah Labhart, and today how David Hartmann is making additive manufacturing scalable by building software to unlock its full potential. This episode is sponsored by Incogni. Listen, guys, I don't know about you, but I get real tired of managing the spam and cold outreach to my contact info. Those annoying emails, phone calls from unknown numbers, wasting our time and valuable attention. Not to mention the bad stuff from data breaches, which are rising every year. To top it off, data brokers out there harvest our information and sell it to people who intend to spam you and scam you. So what do we do about it? Well, I use Incogni. I signed up to use the platform, and within 30 minutes, hundreds of requests had been sent and completed, removing my data from the public view. Incogni tracks down and removes your personal data from online directories, people search sites, and commercial databases. The process is fully automated for the hundreds of known data brokers who sell our data without consent. Got a site that they don't auto-hit? No problem. There's a custom removal feature to take down almost everything that is exposed online. So take it from me and take back your personal data with Incogni. Go to incogni.com/codestory and use code CODESTORY at checkout to get 60% off annual plans. You can also find the link in the episode description. That's incogni.com/codestory, because they can't harm you if they can't find you. This episode is sponsored by NordProtect. In a world where data breaches are on the rise and identity theft is becoming more common, you have to take steps to protect yourself. NordProtect offers you everything you need to keep your identity safe, all in one easy place. It's built to help you safeguard your identity with advanced automation that works 24/7 on your behalf. Things like dark web monitoring, credit monitoring, security alerts, and more. And if the worst should occur, the platform walks alongside you for identity restoration. NordProtect plans come with financial coverage across a wide range of threats, from identity theft to online fraud and scams, so you are covered when it matters most. Get an exclusive 5% discount on NordProtect plans. Go to nordprotect.com/codestory and use the code CODESTORY at checkout. You can also find the link in the episode notes. That's nordprotect.com/codestory. David Hartmann is a German-born New Zealander, where he still lives today. His first job was to spend 17 years at Bayer, getting deep in the materials world, which triggered his passion for 3D printing. Outside of technology, he's raising 2 kids in New Zealand, which he notes is a great place to do so. He also travels a lot, which he loves, and mentioned that traditional cooking for New Zealand is something that doesn't happen often. This type of indigenous way of cooking uses hot stones underneath the earth. In 2014, David took a sabbatical from his corporate job. He started to dig into 3D printing and ended up meeting the founder of Polymer. They started talking about why the industry hadn't accomplished much of the things they had hoped, and they realized that software was generally the answer. This is the creation story of Helio Additive.
We're a deep tech 3D printing software company that's looking to make 3D printing or additive manufacturing scalable by solving some of the core problems behind what's happening in 3D printing, which is really around reliability, scalability. In 2014 or so, I took a sabbatical from corporate, and the idea was we were seeing so much change in digital manufacturing with our customers. I just wanted to explore that in more detail than what a day job could. So I took a year and a half off and started to extend my network and talk to people in 3D printing, spoke at a few conferences, wrote a novel about the future of 3D printing, worked on my doctorate in that area, started a startup actually, which doesn't exist anymore, and met a gentleman who is the founder and CEO of Polymer, one of the leading 3D printing material companies. We got on really well and we started sharing ideas. And then after I went back to corporate, I continued these conversations. And in 2019, started talking about why hadn't these things that we'd wanted to see in the industry, why hadn't they occurred? What was holding it back? And he said something really insightful. We were in Düsseldorf having a beer after K-Fair. And he said something really insightful. He said, look, 10 years ago, we tried to solve these problems with building better hardware, like building better printers. And this was great. We've got great hardware, but it didn't solve the problem. 5 years ago, we tried to solve it with materials, tuning, glass transition temperatures, and so on. Didn't solve the problem, or partially solved it, but not completely. And actually, the only way we can solve it is to really understand the physics behind the material in the process itself. And probably the only way you can do that is through software, because people's brains aren't really wired like that. And that was the trigger that then, about 6 months later, we started Helio Additive with a view to deeply understanding what was going on with the material at a physics level while it was being deposited in the manufacturing process, and then somehow being able to bring these insights to the operator without needing coding or mathematics or deep engineering simulation knowledge, but just by being able to get back, okay, this is the optimized set of process decisions that you should be making here, because any other set of decisions won't take you to high yield, high reliability manufacturing process.
Tell me about what you would consider the MVP. So that first version of Helio Additive, right, where you start digging into the products, you start digging into the physics behind it, and start building that software. What sort of tools were you using to bring it to life? And tell me about that story of its inception.
We started as a deep tech company, which means we had to do 2+ years of what was effectively scientific research before we had something that we could say, okay, this solves the problem from a science perspective. Now we have to do engineering. When we started, there was hardly anything in scientific literature in this area, right? You had, in the metal space, you definitely have a lot of metal welding literature, which would help for this topic for metal, but we're polymer focused. And yes, there is some polymer welding literature, but not a lot. And of course, there's all the rheology literature and so on. But there wasn't a lot from the academia perspective that you could just read through and say, okay, this is the clear engineering path, right? We had to do a lot of experimentation and a lot of going down the wrong path coming back. And I think then, in that kind of situation, you're less likely to build an MVP because you don't want to jump straight to a solution. And what you're more doing is saying, do I understand this industry well enough to believe that this is such a big problem to solve that it's worth spending multiple years on this topic, even if there is nothing I can test? And in our case, we were so embedded in the industry that it was pretty clear to say, yes, we understand this well enough to know there is a problem, and the problem is really big and it's worth spending this time on. So I guess no MVP would be the short answer, but that gives you a little bit the context behind why I would say no MVP. Of course, we were writing code, right? But a lot of it was mathematics and testing and trying different simulation techniques. And not much of it was in contact with customer.
So no MVP, but even during that, couple years of research and digging in, you probably stumbled upon or discovered something that really shaped how you built the product. Tell me about some of those maybe that you ran into, one or two, and how you coped with that information or how you implemented that information to move forward.
So we're a small team, right? We're a startup. At that, we were probably for the first year about 7 to 10 people, some with PhDs, some without, but everybody deep in the technical area. And so we'd have these paper reading sessions. So we'd go through 50 papers that were interesting in a particular field, and you go through and read through them for ideas. Initially, we had an architecture, an idea for how we'd solve this problem that we thought was a pretty neat way of solving it. A combination of machine learning and some other tricks and some material information. And this worked, but was very clumsy, and we didn't have a great idea how this would scale. Often when you do things at the beginning, you don't worry too much about scale. You more worry about, can we solve the problem? One of the recent engineering hires, and what was nice was he hadn't spent 6-7 months diving into this topic, so he was coming at it pretty fresh. And he said, you guys are all making the assumptions that this particular area, you're making the assumption that that's the way you need that you really need that, but what if you don't? And he highlighted something that he'd been thinking about. And everybody was first quite negative because it challenged, why did we just spend these months working on this? But then we quickly built a prototype, and it turned out his approach made a lot of sense. It got us faster results. It got us more consistent results. It was a first principles approach, so it wasn't data science-based approach. And all of a sudden, once that had been proven, then everybody got on board with the new approach. And that ends up being the foundation of the technology we have today. So I think it's interesting how new team members and new ideas can come, even if you're already committed down a certain path. And sometimes you just have to say, or you have to be able to convince the team, what we did in the past is what we did in the past, but now we're going to do this new thing, because what matters is the goal that we're getting to, not necessarily how we're getting there.
So then you put in the time, right? You learn what you're building, you figure out what to build, and now you have it built. How have you progressed the product from there, and how have you matured it? I think to wrap that in a box a little bit, what I'm looking for is, how do you go about building your roadmap? How do you decide, okay, this is the next most important thing, to build or to address with Helio Additive?
So once we realized that we'd finished our core science and that we had something that worked, then it was time to do engineering. And we were really lucky. Our science CTO is an absolutely amazing guy, a PhD in polymer physics and data scientist, so very rare kind of profile. But we knew, and he also said, now we're going into engineering, you're going to need a little bit of different skill set to scale this. And then that came in Dr. Patel, who's our current CTO, and he came in from the automotive industry with a ton of experience implementing closed loop simulation in combustion engines. And he just had the knowledge of what do you do, how do you scale this kind of industrial B2B software at the customer-facing end. And then also came a time to build up a completely different side to the team, right? Because you needed DevOps. All of a sudden, we're cloud native, so there needed to be a part of the team that really understood how do you deploy on AWS, for instance. All of a sudden, a monolithic code base had to be broken down. And I think that's really dependent on the skills of the people that then come in. And right now we're 18, 19 people. And I think we've got a very strong foundation with a tool that can now be deployed widely. We've been working with customers as co-development partners already for the last year and a half or so, where customers will be testing and using the tool in a kind of a limited way, aware that we're still in a development phase and this is an alpha. And now in March, we'll launch our real first market product. Yeah, and that's going to be a really exciting thing. We're very excited about it at the moment.
You mentioned your team. Tell me about how you went about building that team. What did you look for in those people to indicate that they're the winning horses to join you? I'm looking for culture-wise. How are you building that team culture that really gets it done?
So I think my co-founder and I, Dr. Luo and I, we had a pretty good idea of what we think is a winning team and what the values are for a winning team. And the three values that we do have are first principles thinking and deep thinking. So we were looking for people who don't worry about getting dirty by diving into a stack of academic literature and can then synthesize that and make intuitive leaps, and not people who will directly go to a conclusion. We wanted diversity, which we've achieved some of it, but certainly we're nowhere where I would like to be there. That's been very hard. And then the third one was really about being very open. So we wanted people who wouldn't get too emotionally attached with some work that they'd done, but were rather open and honest with themselves to say, oh, this isn't working, we need to change this, or, oh, this is working, but the team's ignoring it, I better push this harder. So these were the three values that we were focused on. Generally, people who joined have stayed, and where they've gone, it's because maybe technically some things were a little bit too challenging, and they felt this wasn't what they wanted to spend the next few years on, so they self-selected out, which I think is also great. I really appreciate people who are honest and do that.
All right, let's go back to scalability then. So, I heard you mention the monolith to microservices and those things. I'm curious about if the solution was made with scale in mind from the beginning, and so that process would have been easier, or were there areas that you had to fight this as you grew and went through that transition?
Always when we look back, we try and invent a story of why something happened. And that's probably not true. Probably it's just a random collection of events and we're mentally putting a story behind it. But if I look back at Helio, I could see two phases. One phase, which was really a science phase, and one phase which was an engineering phase. And my feeling is, in the science phase, it is counterproductive to focus on scaling. I don't think in the science phase, you don't want to spend time writing all the tests for your code, because you're exploring that code may not exist next week anymore. You want to build something fast and check and see what the results are. You also, with language choices, right? For the first, nobody on the team was using something like C or Rust in the first year and a half. Everybody was working with Python. Why? Because most engineers, even if they're not coders, can work with Python. And most of our people were polymer physicists or engineers or chemists, some kind of science special. And then getting into the second phase, the engineering phase, then all of a sudden, the base kind of, yes, we will roll out multiple versions. Yes, now efficiency and scale and deployment on the cloud, now those are priorities, because the fundamental building blocks are not going to change that much. And then it's a time to take things that you've built to prove out what you want to do, and then say, okay, what are the tests we need for this? Are the libraries you're calling here efficient enough to be used by hundreds of thousands of manufacturing sites around the world simultaneously, or do you need something different here? So I think those are two different phases.
So as you step out on the balcony and you look across all that you've built, what are you most proud of?
So right now we have a system where once the printer and material is characterized in our system, for any geography, you can effectively just press a button and get an optimized toolpath out the other end, which is where you can have a pretty high confidence that as long as it's within the printer's capability, it'll print really well. And there were many times in the last 3 years where I thought, we're not going to get there, or this is too hard a problem, or what am I personally doing here with no deep science degree? How am I the appropriate person to tackle this? And I'm just really proud that we've gotten to this stage where we're over the next year, I'll see that technology rolled out to many manufacturing sites. And that gives me a kick. And when I was in corporate, the corporate was fun, and I ran a reasonably large business or 7 reasonably large businesses globally, but the opportunity to have an impact on an industry was minimal. The idea that we've built something over the last 3 years that solves a really big problem and has the potential to have lasting change impact on an industry that I love, that's like being a kid in the Toy Story.
Let's flip the script a little bit. Tell me about a mistake you made and how you and your team responded to it.
If I could go back and talk to young David from 3 years ago, I would tell him, don't be so much on fire for solutions. And ironically, that was something that my co-founder kept telling me, because he has his own pretty big business to run. So he's more research advisor, regularly works with us, but he's not, his full-time job isn't at Helio Additive. And he'd come in and he'd pin to me and say, David, you're pushing these people too hard. You're too focused on what are the OKRs, what is the outcome, when you're jumping on a solution and you're saying, okay, that's the solution we're going to do. We haven't started a path that's going to be solved in 6 months. This is a path that's going to take us years to solve. Be prepared for the marathon. That was probably, from my side, the biggest mistake, is pushing the team too hard when what was really needed was, in some cases, more exploration. What we have now is an agreement. Actually, I hear this quite often. I have an agreement with Priyesh, with our CTO, that I don't task tech team members directly, which is sometimes tempting. We work out of the same office, or yesterday I shared a train ride with one of our new senior developers, and we were talking about some problems. It was so tempting to say, oh, I'd really like to see this data. Can you pull this out and do this analysis and just send it to me so I can show these people? But that's not my job to do that. And every time I do that, I interfere with their priorities. We have this agreement where I won't step in and task any technical team members. Everything has to go through him. And that works really well for us.
This will be really interesting. And I want to hear, I'm curious to hear your passion. What does the future look like for Helio Additive?
Over the next year, we're going to be rolling out our technology in one specific area, which I don't know whether you've ever seen it, but it's this large-scale robot arm-based 3D printing. In the US, you have companies like Cincinnati and Thermwood that do it. The Oak Ridge National Laboratory was heavily involved in it. In Europe, you have companies like Seed, in Asia, Coin. And this is a really interesting form of printing. What they're doing is they're printing tens of kilos of polymers per hour. They're doing things like printing aerospace composite tooling, or even entire boat hulls. So parts that could be 10 meters long, 20 meters long. And one of the problems they have, of course, is they have a tremendous amount of scrap and waste. You can imagine that if a part takes you a week to print and you have a mistake on day 3, that's a lot of wasted material, a lot of wasted engineering time. So this is an area that we're going into first. And then, because our technology is applicable across the scale of additive manufacturing, from consumer to desktop industrial, so then I see us more scaling that technology on a broader base. Over the next decade or so, I think things will change. I think we're a behind the scenes, we're an enabler, right? So I think we are going to be invisible more often than not. So the users may not even see our brand, but rather may see somebody else's brand and our technology under the hood. But I think over the next 10 years, what will stay constant is we'll always do something from a first principles physics perspective, together with software, to drive scaling of additive manufacturing. When you talk to people about 3D printing, many people say, oh, the hype was there and now it's gone. But industrial 3D printing is only just starting to take off. This is already a $20 billion industry, roughly $18-19 billion industry, growing at 25% per year. I think it's pretty clear that around 2030 or so will be a $100 billion industry. And I hope that Helio is at the heart of that.
Let's switch to you, David. Who influences the way that you work? Name a person or many persons or something you look up to, and why.
I think I could name many people, right? Industry people. We have great people on our board, people like Professor Dunn at the University of Colorado, or Stefan Bayer, the ex-founder of BigRep. So people that I know, there's lots of people around me that inspire me. I think in terms of experiences in my life, in 2018, I was really lucky to go on a leadership program in Scandinavia. It was a Danish-Swedish leadership program called Pathfinder. They dive deeply into what it is like to lead people, what your personal leadership persona is, and how the activities that you do impact your purpose in life. And this was, for me, I know it sounds pretty cliched if I say it that way, I realize that, but this was for me life-changing. It's a program that's held by really inspirational people, including a Native American shaman who comes in and does the last session. They hold it in Sweden, out in the very beautiful nature spots. And it was, for me, a real opportunity to think about what am I doing and why am I doing it? And an opportunity to also push myself to my limits and see what am I made of What am I ashamed of? How can I be more self-aware? Even today, if I have topics that give me trouble, I call the people I met during that period and have a brief discussion, and that puts me back on track. So not something that I expected. My peers, most of my peers, chose to go to INSEAD or Oxford to do their executive education in corporate. And for me, this was I thought I don't need more on the IQ side. What I need more is on the EQ side and on the more spiritual side. And getting the chance to do that was amazing.
We talked about a mistake earlier, but this is a little different spin. If you could go back to the beginning, what would you do different? Or where would you consider taking a different approach? It doesn't have to be something that, didn't work. Could have worked well, but maybe you'd tweak it a little bit.
If David from 3 years ago had known how tough and challenging and sometimes heartbreaking it was going to be to get to today. You hear some founders' startup stories, and they're like, oh, this was all amazing. And then we made one call and we raised this amount of money, and it was just easy to get the first hires. And I always listen to the stories and I say, wow, first of all, I'm not sure I should believe that. And B, I'm so happy for those people if it is true, but that's certainly not our path. So I think those challenges and having to suffer tremendously in certain times, either hiring people or raising money or not being sure, are we even going to find a technical solution to this problem? I think if 3 years ago David had known that, he probably wouldn't have had the courage to start this journey. And so I'm quite happy that I didn't know that and that we blindly went into that process and just started working on it just with a belief that, hey, I've got these 2 or 3 amazing people around me. If I can motivate everybody and keep everybody on the same track, then there must be a solution here out there to this problem.
I got one more question for you. So you're getting on a plane and you're sitting next to a young entrepreneur who's built the next big thing. They're jazzed about it. They can't wait to show it off to the world and can't wait to show it off to you right there on the plane. What advice do you give that person, having gone down this road a bit?
Last year I went to Slush for the first time. It's one of the largest collections of where founders and investors get together. I think it was like 14,000 people last year. Certainly met a lot of really interesting people, and I wouldn't say the place to do transactions, but more the place to get inspiration. But then flying to London on the way back from Helsinki, everybody was flying out. Some people's flights were delayed, all the planes were full, and of course everybody that you sat next to had been at Slush. And I was sitting next to a gentleman from Saudi Arabia. We're pre-A still, but he had a Series B fintech startup, and for the 2 and a bit hour flight to London, he effectively gave me advice on what he thought I should be doing. And I think advice is a really tricky thing to give, because yes, you do have the benefit of, let's say, experience that the other person doesn't have, wisdom, but at the same time, it's very hard, or it's probably impossible to empathize completely with what that person has gone through or is going through. It's a little bit like somebody comes to you and tell you they're depressed or they're feeling suicidal, and your answer is, oh, just relax, don't feel so depressed. This is not a super useful thing to tell somebody. So I'm always really cautious about giving and receiving advice. It always has to be put into context. So I think if I had somebody like that sitting next to me, I would probably just listen and maybe ask a few questions and not give a lot of specific advice.
I think that's a very helpful thing to do. David, thank you for being on the show today, and thank you for telling the creation story of Helio Additive.
Thanks for the invitation. Really nice to be here, Noah.
And this concludes another chapter of Code Story. Code Story is hosted and produced by Noah Labhart. Be sure to subscribe on Apple Podcasts, Spotify, or the podcasting app of your choice. And when you get a chance, leave us a review. Both things help us out tremendously. And thanks again for listening.